Record.
Our topic is solar PV, an alternative to fossil fuels. We will begin with the big picture, the climate change and the urgency of transitioning from fossil fuels. We will then discuss solar power, its fundamentals, land use, and emissions benefits before assessing its feasibility in Australia, outlining both opportunities and constraints. And we will wrap things up with some key conclusions. Then, Australia is warming 1.4 degrees Celsius faster than the global average, and greenhouse gas emissions remain the key driver of this change. The energy sector is by far the largest source of global emissions, responsible for about 75.7%. Within this sector, electricity and heat production contribute around 30%, with coal producing about 47% of Australia's electricity. Energy transformation is very urgent here.
And solar is recognized by the IPCC as a central pillar of global decarbonization pathways. What makes solar stand out is Australia's most exceptional resource. Most regions of Australia receive over 4 kilowatt hours of solar radiant per square meter per day, and the north exceeds 6. Photovoltaics have been around since the 1800s, and the first practical silicon solar cell was developed in the 1950s with an efficiency rate of 6%. Today's modern silicon cells exceed 25% efficiency. Further efficiency potential is guaranteed. Combined with production costs falling more than 80% since 2010, solar is now among the cheapest forms of new electricity globally. Even with the integration costs, its LCOE is estimated at $50 per megawatt hour, significantly cheaper than building a new coal plant, which is currently forecast at around $100 to $140 per megawatt hours. And most existing coal plants were built decades ago and are being phased out. When comparing renewables on land use, solar stands out as one of the most efficient options in Australia. Large hydro requires vast areas and causes significant ecological disruption. Biomass competes directly with food production, and nuclear remains politically unviable. By contrast, solar can be deployed at scale with a smaller ecological footprint, and rooftop installations avoids new land use altogether. The only real contender in land efficiency is wind.
So Western Down Farms is Queensland's the country's largest solar farm. It spans 2,000 hectares. It powers almost 235,000 homes. In Earing, the largest coal power station in Australia, delivers about 75 times more output on less than half the land. Comparatively, this shows that utility-scale solar requires substantially more land than coal for equivalent generation, but the trade-off is that solar produces no ongoing greenhouse gas emissions. Given Australia's average electricity consumption is 10 megawatt hours per capita, modelling suggests to have a 100% renewable economy will require almost 1,200 kilometres square land area, and that is approximately 0.02% of Australia's land mass. But the real challenge isn't the amount of land, it's how the land is used. And although there are concerns about solar competing with agricultural land and impacts on national food security, emerging approaches like agrovoltaics allow panels and farming to coexist, reducing conflict and even boosting land productivity. Meeting renewable land demand also depends on having the grid infrastructure to match, which means solar must be located not in totally remote locations, which is most of Australia, but in areas that have existing or future hosting capacity. Some environmental considerations with the change of land use are natural hydrology impacts, biodiversity impacts, and energy balance and microclimate effects. Although substantial land is needed for large-scale generation compared to fossil fuel technology, better storage will make solar's footprint much smaller and more efficient.
Solar energy has one of the lowest carbon footprints of any power source. Across its full life cycle, Solar power produces about 20 to 50 grams of CO2 equivalent per kilowatt hour. Most of these emissions come from manufacturing and transport. By comparison, coal-fired power plants emit around 820 to 1,050 grams of CO2 per kilowatt hour, and natural gas plants average about 450 to 500 grams. Furthermore, once a solar system is installed, its operation is emission-free. No fuel is burned, no CO2 released. So it repays its entire carbon debt within 1 to 2 years. And their lifespan is over 25 years. At end of life, recycling can now also recover 90% to 95% of materials like aluminum, glass, and silicon, further reducing their long-term footprint. In Australia, emissions are still concentrated in fossil fuel sectors. In 2023, coal provided 47% of total electricity, while solar PV accounted for 15.3%. This gap shows the strong potential for solar to replace fossil fuels. Since 2015, renewable energy has avoided more than 200 million tons of CO2, equal to eliminating emissions from all of Australia's cars and planes combined. In 2023, renewables cut 55 million tons, a 30% reduction in electricity emissions compared with 2015. Solar's advantage lies in directly replacing coal. Every kilowatt hour of solar saves up to 1.18 kilograms of CO2 that coal would have emitted. With solar now covering 18% of electricity when rooftop and utility scale are combined, the avoided emissions are scaling up fast. By 2025, the cumulative reduction will reach 340 million tons, with power sector emissions almost 40% lower than in 2015. And because solar pays back its carbon costs in just a few years, then produces clean energy for decades, it becomes even more powerful when paired with electrification in transport, industry, and buildings.
Australia is in a unique position on solar power. We lead the world in rooftop uptake, adding about 3 gigawatts a year, which is roughly 300,000 new systems that can be installed in weeks. Even large-scale solar farms take 18 to 27 months from finance to full output. Together, rooftop plus large-scale projects are delivering about 6 gigawatts of renewables per year, already matching the pace needed through to 2030 to replace coal, whose plants take years to build and lock in far higher emissions. Feasibility isn't only about speed, though, it's also about constraints. Grid connection is a major bottleneck. Commissioning, which once took 3 months, can now stretch to 6, and New South Wales planning approvals for solar can reach 700 days. We also urgently need new transmissions between remote areas where the best solar resources are and the cities and the industries that use that power. Despite these hurdles, solar still remains the lowest cost new large-scale electricity generation, even with storage. And at under $50 per megawatt hour, it's less than half the cost of coal and nuclear in new build terms. Stronger federal capacity auctions also guarantee developer revenue. Unlike coal, solar can be deployed across far more locations, and new GIS mapping is helping pick the most cost-effective solar farm sites. The other challenge with solar is intermittency. Solar gives us midday surpluses and evening shortfalls. The solution to this is firming. Lithium-ion batteries, like Australia's Big Battery, provide fast, short-duration balancing. Pumped hydro, like the Snowy 2, offers hours to days of backup. Snowy 2 also adds about 2,000 megawatts of capacity. And natural gas remains a bridge for quick ramping, although over time it'll likely give way to cleaner alternatives like green hydrogen. Looking ahead, innovations are pushing feasibility even further. Community batteries are already being rolled out through government initiatives. Interconnectors, which act like virtual batteries, like the BassLink, can transfer up to 500 megawatts continuously between Tasmania and Victoria. There's also the planned second cable called the Marinus Link, which has been developed to provide much, much larger capacity of about 1,500 megawatts. Floating solar can also deliver land use efficiency gains and has been trialled in Burrendon Dam in New South Wales. And finally, green hydrogen has the capacity to extend solar's reach to decarbonize heavy industry, shipping, and even aviation, with $2 billion of government incentives already on the table. This could seriously extend solar's reach from electricity into the wider economy to offset carbon emissions.
Bottom line is sunlight is abundant. Solar PV is fast, scalable, and already the lowest cost source of new electricity. It's land efficient when installed on rooftops and outperforms fossil fuels across its life cycle emissions, supporting Australia's decarbonization goal. The only real barriers are grid integration, planning, and storage. With reform and enabling technologies, Australia can not only replace its own fossil fuels, but also position itself as a global renewable energy exporter. Okay, thank you.
The end.